Welcome to Ask and Learn.
This problem asks us to first draw a complete binary tree with 15 vertices that represents a tree-connected network of 15 processors. So what we know is that we have 15 vertices, and it's a binary, which means our m is going to be 2. So we need to know how many leaves we're going to have at the bottom, just to verify. It says full, but we want to verify. So I'm going to use the formula L equals, and then m minus 1 times m, n plus 1 over m. So we know that m is going to be 2 minus 1 times the 15 vertices over 2. So this is going to be 2 minus 1 is 1. So 15 plus 1 over 2, which is going to be 16 over 2, which is 8. So that lets us know the last level we're going to have 8. Okay, so let's go ahead and do processor 1. And since it's binary, it can only have 2 processors attached to it, so P2 and P3. P2 can only have 2, so P4 and P5. P3 will have P6 and P7 attached to it. So right now we're at 7 vertices. And so P8, P9, P10, P11, P12, P13, and then P14 and P15. So we have 8 at the bottom, so that works out perfect. So that's part A. And then part B asks us to show how 16 numbers can be added using the 15 processors in part A in 4 steps. So if we have 16 numbers, I am going to let A1 to A16 be my numbers 1 through 16. Okay. So if let's say I let the bottom processors add, since there's 8 of them, I let them each process 2 numbers. So I'm going to let P8 process A1 plus A2. P9 do A3 plus A4. P10 is going to do A5 plus A6. P11, A7 plus A8. 12 is going to do 9 and 10. P14 is going to do A13 and 14. And then P15 is going to do 15 and 16. Okay. So now if each one of those is adding to it, we eventually want P1 to actually process all of the numbers and have an answer. So P4 is going to process what P8 and P9 did. If they can only process 2 numbers at a time, that means that, let's see, was this P4, so 4, 5, 6, and 7. So P4 is going to process P8 and P9. P5 is going to process P10 and P11. P6 is going to process P12 and 13. And then P7 is going to process P14 and P15. So then if we go back up here, then we're going to have P2 process P4 and P5, and then P3 will do P6 and P7. So then last but not least, if we go back up here now, we're down to the last step. So this will be the fourth step, which is where P1 is going to process P2 and P3.